All right, so today's lesson should be a little quicker. With any luck, we might get done early and have time to mind trap. So the big thing we're doing here today is talking about which sampling method is better. So let's look at this situation. We have a radio station, and the manager wants to kind of give like a staff appreciation meal. So a lot of times, people like food. So if you want to show appreciation, you can get people food.
Yeah.
So he decides to survey his staff. They both systematically sample every fifth worker by last name. How would their recommendations end up so different? One of the managers, the manager and the owner. So the manager got the answer that everybody wants the salad bar. Almost everybody, majority wants the salad bar. The owner, when he surveyed, most people said they want a breakfast bar. Why could their answers be so different? Bunger?
Because they started on a different person.
Could have been started on a different person, but you wouldn't normally get answers that are so different from each other. Oriana?
Different times in the day.
If they performed their survey at different times of the day, those individuals are going to have different biases because the morning staff is going to want the breakfast bar probably, and the afternoon, evening, even midday staff is probably going to want the salad bar. So time and place have a big effect on your data. So on your notes, you want to write that time and place affect your data. I got to pull up the people. Pulling up the wrong folder. Apparently I need to orient. Is what? Yeah, who knows the answer and why? Yeah, cause and effect versus affect. If you have an affect on something. Sampling 7. So time and place. Or if you want to avoid that word, you can say change your outcome. Because your outcome is what you find at the end. So the two different outcomes are a salad bar and omelet bar based on when they collected the data. So you could even put up here like morning crew or something like that. And the daytime. One of my favorite things about college was we had an omelet bar where pretty much every morning you could go just choose whatever you wanted and they'd make you an omelet with it. And sometimes they'd have leftover steak from the night before and stuff. You get a steak omelet.
What?
Steak. Like if they had steak the night before. Alright, so during the final...
And now, America, you have voted and voted as many times as you wanted. And as always, we have tallied the votes. And this week, just as we have every other week, the lowest scoring contestant will be eliminated. But America, tonight is different. Because tonight there will be only one contestant remaining, and that contestant will be the singer the country has declared is #1. Can you believe it? And we'll find out the results right after this commercial break.
Whoever watches American Idol or any of those, The Voice, any of those things. So when they have people call in and vote, he said something really important there, that announcer dude. He said, you voted and voted. Eli, Thomas?
Multiple times.
Yeah, as many times as you want. Are you limited to only one vote for American Idol or those things?
No.
How do they limit it? Because they actually do limit it now a little bit.
It's 10 times or
You can vote 10 times per method. You could vote 10 times by texting. Then you could go online and vote 10 times on the online submission. Then you could call, if you have a home telephone, you could call in 10 times and vote. So one person can vote a lot of times. So when we think about the statement, the winner is the singer the country has declared #1. Is this a valid inference? So I want you to take a moment, write down on your paper, do you think this is a valid inference and why? based on our conversation, you should be leaning one way or the other. Do you need a bag for those, Karina?
No.
Okay.
No.
I didn't know if they if your bracelet broke or something.
No.
So either no, this is not valid because, or yes, this is valid because. And I will go ahead and say, and maybe save a couple of you some time. Is this a valid inference? No. Why is this not a valid inference? Thomas?
Because they can vote as many times as they want.
And did everybody in the country vote?
No.
Yeah, no.
No,
Maybe
I don't ever
one
vote.
person voting, get that guy off, get that guy off, get that
Yeah.
guy off, get
There,
that guy off.
there could
get that guy
literally
off,
be
that guy.
one person voting. Thomas just said there might just be one person voting. You never know how many people are actually voting because a lot of human mentality, people think, oh, somebody else will do it. Oh, they were the best person. Somebody else will vote for them. I don't need to spend my time voting for them. So this is not valid because not only did not everybody vote, but the people that voted could vote multiple times. When we're collecting data and we want a representative sample in an unbiased way, we can only let each subject that we choose vote or answer one time. That's why when we randomly generate those numbers, if I generate the same number multiple times, I don't ask the same person again. I generate a new number and I move on to a different person. A lot of times, and what it said up there, a lot of times, people's friends and families will vote 10 or 20 or 30 times. I know when my brother's girlfriend was in this Columbus singing competition thing, I voted for her as many times as I was able to. Until some voting methods, though, it looks at your IP, your internet provider address, and it says, oh, you've already voted, you can't vote again. So some voting things are locked down to only one time. Other things like American Idol, because they charge you, they want you to vote multiple times. Because when you send that text message, it charges you. So a researcher asks 5 of his dentist friends if they thought the new Brand X toothpaste that he developed was effective. 4 responded yes. And the researcher used this information to write a TV ad claiming 4 out of 5 dentists prefer Brand X. Is that valid?
No.
Oriana?
No, because they were his friends and it was biased.
Ooh, I didn't mean to capture. His dentist friends, if they thought Brand X toothpaste was the most effective. How many dentists do you think there are in America? A lot's not a number. Somebody said 1 million. Maybe not 1 million. We'd have to look at the population. Yeah, at least hundreds of thousands probably. So if you only ask 5 dentists, do you think that is a valid sample? Do you think it's representative of all dentists? No. So, first off, they're his friends. Second off, my sample is way too small. 4 out of 5 dentists. Now, why is it that lots of commercials will say 4 out of 5? Did they only survey 5 people?
No.
No, what do they do with the data?
They simplified it.
They simplify it. They round it, and they simplify it. I think we have time in the lesson. I'll do this real quick. This is an example of when they really do not want you paying attention to the data. They more so are just trying to make a commercial that will be entertaining, and then maybe you'll remember it. So
4 out of 5 dentists surveyed would recommend Trident to their patients who chew gum. But what about the 5th dentist?
Now then, would you recommend Trident for your patients who chew gum?
Yes.
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 There are many theories, but one thing's for sure. Great tasting sugar-free Trident helps fight cavities.
do you think when people watch that commercial, they actually thought like, oh, that fifth dentist really doesn't like Trident. No. All they remembered was, oh, you remember that funny squirrel commercial? So when they are advertising, even though that was real data that they collected, they're trying to skew how they present it, so you think only one person said no and something else happened that made him say no. Sorry, it's getting grammatically incorrect. So be careful with advertising. Advertising almost always is skewed, biased, not valid. It's almost always got an objective with it. That commercial is kind of old. I think it's been around for a while.
Don't go to the fish. Let the fish come to you.
It's easier to move upstream if they get out of the water, so they jump as they go. So you've gone to college, and this is actually, I thought about becoming a wildlife researcher. I love the outdoors, I love camping, I like animals. So you decide to follow that path and you become a wildlife researcher. You want to know the total fish in a lake. Obviously, you cannot count every single fish. That would take a while. You catch and tag 50 fish from the lake. What is it when you tag something?
You put mark it with something.
Yeah, so a lot of times, like, if you've ever been to a fair or something, you'll see a lot of times cows or animals like that will be tagged on their ears, because your ears often have very few nerve endings. That's why we can pierce our ears and it doesn't really hurt very bad. Yeah?
And ornithologists will put little rings around birds' feet, usually to track migration.
Yeah, so that they don't have to actually poke anything through it. They put like a little zip tie ring around it. And a lot of those, because technology's gotten cheaper, will have a chip in it that is either a GPS chip or it just registers, like it has a number or something on it, so when you scan it, like whose dog is chipped in here? Has like an implant chip? Yeah, so you scan it and you know who it is, what data, like where they found it, all that stuff. So we tagged 50 fish from the lake. You then release them back, because obviously you're a researcher. You're not trying to catch the fish, you're trying to collect data. A week later, you catch another 50 fish. Do you think you caught the same 50 fish? No. But 15 of the fish that you catch today are still tagged, like are the fish that you had caught the previous week. So how could we use this to predict the total fish in the lake? What do you think? Anyone have any good ideas? Ethan?
Put 15 over 50 and that in.
So if I put 15 over 50, that would be the tagged fish over the total. Right?
Would it be
How do I relate that to the total fish in the lake? Should there, if my sample is representative, should there be a relationship between sample population and the next time I collect sample population and the next time I collect sample population? If my samples are always representative, should there be a relationship? What kind of relationship? Starts with a P. It's a huge word for this year. Proportional. So we set up a proportion. And since I had tagged on top over total, now if I want the total population, and that's what I don't know, how many are tagged out of the whole population?
50.
That's how many are tagged in the sample I just caught. How many are tagged out of the population? 50. So now we set up our tagged out of the population over our tagged out of our total sample. Because this, if it's representative, should have a proportional relationship. How do I solve any proportion? This always works. I could simplify and I could do some other things, but what method always solves your proportion? Well, cross multiplication. Sorry, what'd you say after that? And then divide. So we want to cross multiply. So we're going to get 50 times 50. That will equal your other cross multiplication. I'm going to use P for population. I'm going to switch that to just a variable. 50 times 50, multiply the 5s and bring down the zeros. 5 times 5. 25, and we have 2 zeros, equals 15p. So now what do I do to get the p by itself? Yeah, Luke?
Divide 250 by 15.
Ooh, divide 2,500
Yeah.
by 15. Now red's not working? That leaves p by itself. 2,500 divided by 15. Yeah, you got it?
It's 166.6 repeating.
So approximately 166.
Yeah.
Because we would round
Technically
that down.
167 because it's
Wait,
0.6.
oh, 0.6. I thought you said 0.16 repeating. 0.6 repeating is 2/3, which then would round up to 67. And we can label that fishies. Or we could be all creative. Make a little fish.
Should make a mouth.
Except it looks like negative now.
Yeah, but it looks like a goldfish. That goldfish looks so creepy because of the eye. Yeah, just.
I'm not an artist. My sister stole all the artistic ability. It's okay.
What were you left with?
Mathematical ability.
That's better.
I'm way better at math than she is.
You don't say that.
It's not opinion, it's factual.
What if your sister was here?
He'd still say it?
Well, first off, she's in South Carolina, so she's probably way happier than us because it hasn't snowed in South Carolina for a while. And she would agree. Yeah, she would say I'm bad at art. She'd say when I draw a person, it's a stick figure. Okay, so suppose you're now a wildlife researcher. Use that same method with the deer population. So I want you to do this on your own. You're going to set up a proportion that relates your amount tagged out of your total to the amount tagged out of your total, but one should be looking at the whole population, one should be looking at your sample when you came back. Oh, this type of research really does happen. This is how they determine. Anyone hunt in here? Yeah.
My uncle and
Less and less people are hunting now as we get further along. This is how they determine how many deer tags you're allowed to have. Because they go out, they collect data, they figure out how many deer are in the population, and they figure out how we need to control it. Because if we let the deer population get too high, it's really dangerous. Because people hit them with their cars and everything. They end up like fighting in people's backyards. So that's why they let hunting happen. Do you know the population of the deer? That's not the total population. That's how many you saw when you flew back over the area. Do you know the entire population of deer? No. So that's what we're solving for, right? So part of my proportion, one side of it, should be how many I tagged over my unknown population. Then the other side of it should be how many I saw that were tagged out of that sample when I came back, out of the total that I saw when I came back. Anyone able to tell me where I should put these numbers and where I should have a variable? Ethan?
You put 64 over 1,200.
I'm gonna actually do that over here. I agree.
And then you put 100 over P.
So what we start with is knowing when I went and tagged the deer, I tagged 100 out of all of them. I don't know how many there are, but I tagged 100 out of all of them. Then when I fly over that same area, let's say we tag their ears with like a bright orange tag, I can see it from the plane above. When I fly over that area, I see that there are still 64 deer that I see with tags, and the total deer that I saw that day was 1,200. Maybe I had like a computer helping me out or something. That's a lot of deer to count. So I still have 100 over P is tagged over total. 64 over 1,200, that's tagged over total. Any questions on why we set up our proportion like this? Yeah.
I set it up differently and I got the same answer.
Did you have switched around?
I did 64 over 100 and then 1,200 over P.
So you did part tagged out of total tagged, and then part we saw out of total population. That's fine. You just did not set up tagged over total. So you did part over whole for both of them. So Bella set up, just 'cause she asked and I might as well show it. Bella set up her proportion as part we saw tagged over the total that we know are tagged equal to part that we saw like I don't care whether they're tagged or not, but that's how many I saw out of the total population. Notice 64 will multiply by P here. 64 will multiply by P here. 100 will multiply by 1,200. 100 will multiply by 1,200. So you end up with the same cross multiplication. That's why you get the same answer. That's why that works. So this becomes 1, 2, 0, 0, 2 extra zeros. So 120,000 equals 64 times P. When I do the division on both sides, my total population is, Karina?
1,875.
1,875. Anyone verify that?
Yeah, I can verify that. Also, that's a really small park.
Yeah, that is not a very large deer population, but depending on how big the park is. So, like, I mean, Ohio has a few different parks in it. We've got Wayne National Forest. That's down. If you ever drive to OU or you go anywhere like the Carolinas, you'll probably go past Wayne National Forest.
There's a lot of parks. Like, I go to a lot of them for
Yeah,
races.
there's Dillon State Park. There's
Bryan State Park.
yeah, and there's a difference between a state park and a like wildlife preserve and a national park. Like, there's a bunch of
And
differences.
this is a reservation, so that's a really small deer population.
And they probably don't allow hunting because it's a reservation. So maybe they're trying to build up the population.
It's a small deer population.
Let me tell you, venison jerky. It's like the best thing ever.
Buffalo jerky is really good too.
Venison is what you call like the meat that you get from deer, and when you make it into jerky, like beef jerky, but it's venison jerky, it's really good. Because deer is really healthy. Most of what they eat is like plants and essentially plants and fruits probably. So the meat is super healthy. Now I say this with my wife being a pescatarian; she doesn't eat any animals aside from fish. So, you know, whatever you decide to eat or not eat, more power to you. But I've had. I didn't say it was healthy. I said it's tasty. And I'm talking about deer jerky. But it is important that we control the deer population because it's dangerous. All right, so you're now working at a grocery store. Some of your peers, actually, a few of the 8th graders are working at Kroger now. So do not think like you can't get a job till you're an adult. You can get a job once you're 14. Yeah, all you have to do is get a little worker's permit. All right, so let's check this out. The manager of this grocery store wants to know how many bananas to buy for next week. Now, this is actually really important. Why is it important to know how many bananas to buy? Let's talk about the reason we collect data like this. Who has bananas at home? Right, your parents buy bananas, you eat them. What happens to the bananas in about a week? They turn brown and go bad. My brother-in-law, my wife's brother, actually works for a company that, as funny as it sounds, they make and install banana ripening rooms. There's a very specific scientific method to speed up or slow down the ripening of bananas. So there's a lot of data that goes into how many bananas do we order, because what happens if they don't order enough? If you don't have enough supply, the demand is going to be really high, and I'll probably run out of bananas, and then my customers might be upset that I don't have any bananas, and they might go to a different grocery store, and I might lose that customer. What happens if I order too many bananas? Yeah, I'm going to pay for all these bananas. They will probably go bad, and I'm going to lose money, or maybe I have to mark them on sale, and then I probably still will lose money. So we got to figure out how many bananas we want to order so that this manager can keep their job. Because if they order the wrong amount of bananas, the owner might get mad, he might fire them. So this manager stands 2 different places and asks, are you planning to buy bananas next week? Let's look at the 2 different places. So assistant manager 1, the first location, or the first manager, however you want to look at it, took a convenience sample of 23 out of 25 people said yes to buy enough bananas for everyone. But a systematic sample found that 15 out of 30 people in the entire store said yes, so buy enough bananas for half the customers. That found out that about half. What do you think the differences in how they collected their data could have been? Obviously, one's a convenience, one's a systematic. So that's the first thing I would underline or highlight, that this was a convenience and this was a systematic. So we have our differences there. Our convenience sample found 23 out of 25. Oriana?
Maybe since it was convenient, they might have been by the bananas or in like that general area, like that fruit vegetation area.
They were probably in the fruit section.
Yeah, and
Near bananas. Do you think being near the bananas would make a difference on whether people are buying bananas or not?
also, the second one, it says of the entire store.
Yeah. This is the entire store. Which of these do you think is a better sample? Emerald? Why?
It's like the entire store, there's no bias.
What do we know about systematic samples?
It has like a system that has like
It's going to end up giving us what kind of sample?
representative.
A representative sample. So this will be representative. And therefore, it's better. So maybe assistant manager 1 did not pay attention to math class and did not realize how important bias is. Maybe reprimanded somehow. Because if they had ordered enough bananas for every single shopper they have, and if they should have only ordered half as many, they'll end up with a lot of extra bananas.
But some people don't like bananas.
I know, exactly. That's why this sample seems like really 23 out of 25 people. That would be percentage to get the 25 to 100, just multiply by 4. So 23 times 4, break it up, 20 times 4 is 80, 3 times 4 is 12. That would be 92% of customers buy bananas. That's not true. Like, you can just know from the get-go. That's I doubt there's many items that 92% of people buy, not even milk or bread or eggs. That, like, there's really popular items, but I doubt that bananas are.
How do people not get milk? I mean,
A lot of adults stop drinking milk because your body doesn't need it anymore. And eggs are just you decide if you want it or not.
But you need it. You need eggs to make a lot of
Milk is so good. I love milk.
I asked my dad if he should make milk for adults, and he said yes.
All right, check out the Got It. Because my smart board's taking a moment. Check out the Got It.
We're gonna get to play Minecraft, right?
Yeah, we should.
Yes.
So now, assistant manager 3 comes into play. The new manager on the shift. And they say, you know what? I've got a different method. I'm going to use a simple random sample. So, assistant manager 3 uses their simple random sample, and they find that 30 of 50 people said yes. So, we see simple random of all the customers in the store. We found 30 out of 50. So, the big question is if you're the person placing the order, do you change your order? You had gone with manager 2, which was about 50%. So we were going to order enough bananas for half of our customers. Manager 3 found 30 out of 50. What will 30 out of 50 be as a percent? As a percent. If I have 30 out of 50, to make that a percent, we need to make it over 100. So that becomes 60. So this is 60%. Manager 2 said 50%. Manager 3 said 60%. What do you think? Would you change your sample? Take a moment, write down your answer, and why. Answers on both sides can be right. Yes can be right and no can be right. It's all how you justify it. What evidence do you cite to make your decision? Surely, if you need some structure for what answers we're looking at, we could say yes, simple random always collects the best samples. We could say yes, the results show the manager should buy fewer bananas. No, because systematic samples are the best. So now we kind of have an argument. Is simple random better or is systematic better? And no, the third sample matches the second sample, so there's no need to change. So there's just some possible answer choices that you have. Eli, what do you think?
I think yesterday you explained if there's like data that's like streaming through, which is the people in this case.
Okay.
Then you should use systematic sampling.
Okay. So systematic will be easier for sure, and it should still collect unbiased data. So are you saying that we should change our order or leave it? Change to go with manager 3, the simple random?
No.
So stay with manager 2, the systematic?
Yes.
Okay, so Eli's saying stay with manager 2. My data was streaming past me. I could stand at the door of the store. I should stick with that data. Ethan?
I think you should change because there could be a pattern that causes a bias. So maybe they were standing like maybe in like Whole Foods. They have like when you enter, there's like the fruit section and the vegetable section.
Yeah.
They could have been standing at that door when they entered.
Okay, so
Or Kroger, because that happens too.
I like your thinking, but what you have to think about is could there be a pattern in banana buyers?
Yes.
You really think people are going to enter the store in an order based off whether they buy bananas or not? Like if I'm standing at the door and I say, are you buying bananas? And they say yes, and I say, well crap, so am I can't go in yet. I have to wait for somebody not buying bananas before I can go. So I know it's funny, but hold on. Stay with me. Do you think there could be a pattern?
No.
Do you think there, okay, not could there be. Do you think realistically there would be a banana buying pattern? No, we would, like, that would be really weird. It would almost be like an anomaly if there were a pattern that showed something like that. So we don't.
Random still collects usually the best because there is no possible way for it to be a bias.
So here's the thing. Because manager 2 and manager 3 are so close to each other, I would accept answers on either side of this, as long as you justify why. You could say, my data was streaming past me, a systematic sample is better, I got 50%, I'm going to stay with that. Or you could say, a simple random is always better because they say it best represents our population. But here's the thing. How far apart are 50% and 60%?
10%.
Yeah, 10%. They're not very different.
I would still go with manager 3 because you might want to have more, like, just in case, you know.
Yeah, there could be a high demand.
You know what I would actually do? And I bet some of you have thought of this, you just maybe didn't say it.
55%?
Yeah, go right between them. Since they're so close to each other and both samples should be valid, I would just order 55%. I'd cut between them. Well, okay. It's not an option, but in life you really have all of the options. Life is not multiple choice. Life is you got to figure out how to solve these problems. It's like a choose your own adventure book, right?